So hello everyone, we are continuing with the SolidEdge series of drafting. We have already seen how to take these different types of views. We have seen how to apply the dimensions. Now we are going for the tolerances. So to start with, I am having this well-made structure here and we have given the dimensions also here by considering different types of views. Now we need to apply the tolerances where required. So we will see what are the different types of tolerances and how they are applied. Now the definition of the tolerance, we can spell it as deviation from the exact value without affecting the working of the particular feature or object. Means tolerances are applied to compensate the differences which are occurring by the exact value so as to make the part work correctly and also support the interchangeability between two parts. So to start with tolerance, we just need to select the value on which we want to apply the tolerance. So I'm going to select this value here. Now this value is representing the vertical distance from ground till the bottom face of the structure. The value is given here as 200 mm, we can see here. I'm going to select that particular dimension. And for tolerances, you have this option, that is tolerance. You just need to select on this symbol. Here are the different types of tolerance which can be applied in SolidEdge. So first one is nominal. Here the tolerance value is not considered, only dimensional value is given. That's why by default setting is on nominal. We'll change it here. We are going to say unit tolerance. Now unit tolerance stands for bilateral tolerance. There are total three types of tolerance: bilateral, unilateral and symmetric. There is one more type of tolerance type which is called as limit. We are going to see that also here. So to start with, first I am going to select this type, that is unit tolerance. Here you will get the options for applying the plus and minus values. So I am going to click on this box and put up the tolerance value as 0.2 at the plus side and 0.1 at the minus side. Say OK. Now you can see here. To understand it better, we are going to make the text orientation horizontal. For that, I am going to select A styles, select ISO and modify, select the text, and for proper horizontal orientation, I am going to select this orientation option and say horizontal. Say OK now. Say apply and close. Now you can see the tolerances we applied were plus side 0.2 and minus side 0.1. But instead of point here it is appearing comma. So for that also we are going to go on A styles. Select ISO and say modify. Select units and change the delimiter type as period. Say OK, apply and close. Now you can see it is showing point here. So now the value becomes 200 plus or minus 0.2 and 0.1. This is the bilateral type tolerance, means the tolerance will appear at the plus side also as well as on the minus side also. But as the values are different, first one is in plus side 0.2 and the second on the minus side is 0.1. Both are unequal values, that's why they are considered as bilateral tolerances. But if I make this tolerance value same, suppose if I click on this value again and say 0.2 on the minus side also, then this will be called as symmetric tolerance. Means it is a kind of bilateral tolerance only, but the value at the plus and minus side is equal. That's why it is showing plus minus 0.2. So this kind of tolerance representation is known as symmetric tolerance. It is kind of bilateral tolerance only. Next type we are going to see here is select the value again and go for this tolerance option. Here we will see another type is limit. So in limit, whatever the tolerance in plus and minus side you have added will be added in the main value itself. At the plus side we added 0.2, that's why the value is coming 200.2. At the minus side also we have added symmetric tolerance 0.2, that's why the value is coming 199.8. The next type showing here is basic. So here the basic tolerance means it is a theoretical exact value which is not considered by the tolerance. Means tolerance are maybe applied there, but for this particular view the tolerances are not considered for this dimension. So that time you can show the rectangle around the dimension representing it as a basic value. Next we will see unilateral tolerance. For that I am going to select the value again, select the tolerance type, say unit tolerance only. But for unilateral means tolerance is going to be considered at only one side. either plus side or minus side. So suppose if I take here the value as 0.2 and 0.0, and if I go for both the symbols as plus only, for that you need to click on this minus negative sign. It will be changed to plus. Now both the values are coming at the plus side. You can see here 0.2 and 0. So this kind of tolerance is nothing but unilateral tolerance. If I want to take these values at the minus side, select the value again, go for this minus option. I'll select 0.00 and 0.3, 0.30 at the minus sides. So here you can see now the tolerance is coming at only one side, that is at the minus side. So this kind of tolerance representation is nothing but unilateral tolerance, only at one side, either minus or plus. Now for changing the symbols, just need to click on this symbol option here. You can see it can either become plus or minus, whatever we required. Now the next type of tolerance we are going to see here is this S7 class tolerance. This tolerance stands for fits and tolerance. So wherever the dowel holes are applied or whatever hole we required fitment there, we can use this type of tolerance. So to start with, I am having one hole here. You can see on this plate, we have taken the detail view. So here the detail view C has been considered for that particular view. So here is the detail view. We are going to go for the smart dimension option. And we have in between this hole, that is dowel hole. So I have given the value for the dowel hole by using smart dimension only. We don't use here the hole callout option, because if I select the hole callout option for showing the dimension of this hole, we may not be able to apply the fit tolerance there. That's why we have avoided hole callout, and instead of that we have taken smart dimension. Now to show the fits and tolerance here, we just need to select the value, go on this tolerance type, select H7 class. As soon as you select the H7 class, it will ask you for the subtype. That is, if you want to show only fit or you want to show fit with tolerance, you can also show fit with limits or user defined. So we will consider here as fit with tolerance here. After showing fit with tolerance as a type, you just need to select this whole option here. As we are applying tolerance for the hole, you are going to select the whole option, and you can see different types of fits are being shown. Now if I select the shaft option, all the fits alphabetical letters will be shown in small size. And when the hole type fit is selected, all the fit values are being shown in capital letters here. So for shaft, small letters are used, and for hole, all the capital letters are used. So by this way you can distinguish whether the fit is for hole or shaft. I am going to consider the fit here as F6. So as soon as I say F6, you can see here the predefined tolerance will be applied by this F6 fit. So here the tolerances are predefined by the fits. If I change it, suppose if I want to change, I am going to select the dimension type again, select the type, click on this whole option. Instead of F6, I am going to apply N7 now. So for N7, I am going to click here. You can see it is a unilateral type of tolerance being showed here. So in this way you can apply fit and tolerance. Now suppose if I want to show only fit here without showing the tolerance display, so you just need to select the value again, select the type here as only fit, and you can see diameter 4 with fitment of N7. But as this N7 is predefined fit, manufacturer will by default take the tolerance value which is predefined for this N7 fit. So in this way you can show the fits with tolerance. Again, if I want to control this position, select the dimension and go for the type of tolerance required. Select on this X mark, I'll say bilateral tolerance. At the plus and minus side, I'll consider as 0.01 and 0.02. You can see here, bilateral tolerance has been applied. The text size of this tolerance is coming smaller than the dimension size. It is because this setting is predefined, but still if you want to change, you can go here in A styles and select the modify option for ISO. Go on the text, and here you will get the tolerance text. Now the tolerance text size is showing size equals to 0.5 times the font size. So by going on this A styles options, you can apply the tolerance text size as well as you can change the dimension text size also. So these were the tolerance and types and dimensions of SolidEdge. So after dimensioning and tolerances, we are going to continue with surface finish symbols and applying welding symbols. So first we need to ask a question here. Are you tired of your designs not meeting surface finish standards? I'll show you how to master surface finish in SolidEdge, ensuring your projects stand out and meet all specifications. So let's dive in. We are continuing with the previous lecture of dimensioning only. So for SolidEdge surface finish symbol, we have this icon here. In annotation tab, we have surface finish symbol option. So before applying the surface finish symbol, first we'll understand the types of surface finish symbols. For that reference, I have referred one image here, you can see. In this image, there are total three types of symbols being shown. First one is without horizontal line or without any circle, only two lines are there. This symbol represents surface may be produced by any method. Means it may be material removal required or it may be material removal prohibited. Second one is material removal required, in which this line will be added, the horizontal line. And the third one will be material removal prohibited, in which the circle is included here. So these are the three basic types of symbols which we are going to see while applying the surface finish symbol. Now we will see the initials which are used in surface finish symbols. So at this left side line, at the lower side is machining allowance. You can see here. At the above side, we will show the roughness average values. Here will be the roughness sampling length below this line. And at the above side, if the machining removal is required, then it will show the machining process. Whatever will be the machining process will be highlighted here. This symbol will stand for lay symbol, means direction of lay, how the material is removed and what are the patterns made while removing the material on the surface. That is nothing but showing by the lay symbol. So to start with, we'll go on the software here. We'll select the surface finish symbol. First one is basic, which is shown by horizontal line. So we are going to see all the symbols which are shown by this horizontal term. So we'll start with the basic symbol. If I go for this basic symbol, it means manufacturer will decide which method to be selected will be appropriated. It may be material removal method or it may be non-material removal method. Second symbol we are going to see here is machining horizontal. Here the machining will be compulsory, means material removal will take place. And third one will be no material removal horizontal. In this symbol, compulsory machining will be prohibited. Means whatever the machining process will be, material will not be removed in that process. We will go for this machining horizontal. If I go for machining horizontal, it will ask you whether you want the machining to be done on whole complete surface or partially. If you are going for partial surface, we don't need to click on this icon. But if we hit on this icon, it means all around machining symbol will be added, which specifies that complete surface should be machined. The next thing will be surface finish values. So I'll go for this value as 0.07 maximum and 0.03 minimum. These values will be expressed in microns only. Here we will mention the machining process. So if you want to go for the machining processes, we'll refer one chart here. So here we have one chart. In machining process, for material removal, there are multiple ways of machining. So these are the categories and these are the subcategories we can see here. Traditional machining, in which cutting takes place. So for the circular shape, basic conventional machining processes are turning, boring and drilling. There are various types of different shapes also. For that we have milling, planing, shaping, broaching, sawing, filling, gear forming, gear generating and more options such as milling, grinding, superfine grinding, etc. There are some non-traditional machining processes also such as chemical machining, electrochemical machining, electrochemical grinding, EDM, electrical discharge machining, which is very much used for holes, laser beam machining, abrasive jet machining, water jet machining, plasma beam machining and ultrasonic machining. So these are the machining process in which compulsory material will be removed. There are some process in which machining is provided, still the surface finish can be obtained. We will see that processes also. For that we have one more image here. So in this image we can see here This symbol with two lines and circle represents material removal will be prohibited. So for this machining prohibited, processes will be such as casting, forging, hot finishing, cold finishing, die casting, powder metallurgy or injection molding without subsequent removal of material. So material will not be removed here, but still surface finish will be maintained. So these are the processes used for surface finish with material removal or without material removal. But if the basic symbol, this symbol is taken, then surface finish may be produced by any method. There is no restriction for material removal or non-material removal. We'll again move to software here. So here we have taken machining horizontal. We have said all around symbol. We have given the roughness values in microns. Now time to show the machining process. I am taking here as turning now. Next, surface lay. So the surface lay direction means how the material will produce the pattern while removing the material. So it may be perpendicular to the workpiece, parallel, cross, circular, multi-directional. So I'll take multi-directional here. Next is the allowance. Now this allowance is compulsory. Only the extra material or allowance is kept, then only machining is possible. So the machining roughness values we required were 70 microns to 30 microns. So for that I am going to keep the allowance here as 0.2, means 200 microns. So here the allowance is 200 microns. By machining processes, we need to bring the surface roughness between 70 microns to 30 microns. Now if you are using machining process, you can also show the number of triangles. So maximum number triangles are showing here as 4. So if I take the number of triangles as 4, your machining surface finish will be very much high. If I go for one triangle, the surface finish or roughness will be high. Machining will not be that much smooth. So by showing these triangles also we can decide whatever type of machining surface we required here. I'll say it OK. You just need to say OK. Click on the surface and place the symbol where required. So in this way you can show the surface finish symbol here. This is the allowance value. This is maximum and minimum roughness value. Machining process is turning. All around means complete surface is to be machined. And the lay directional will be multi-direction. Means the pattern produced will be multi-directional on the surface while removal of material. So this is the explanation for this icon. Number of triangles are representing the surface finish. How smooth the surface finish should be. Lesser the triangles, surface finish will be less. More the triangles, surface finish will be more. Next we are going to go for the welding symbol. You just need to select the welding symbol here. In this welding symbol option where the properties are shown, you just need to go on this icon, select the required welding symbol. I'll say fillet weld. Need to give the size for the weld in radius. Then we are going to go for the finish required after welding. So I'll take it here as counter symbol. Next, length for welding. If you are going for partial welding, then we need to put up the length also. So I'll take here the length as 15 mm. We'll change the radius value as 5. Next, whether this welding is to be produced all around or only at particular edge. So I'm going to go for this symbol here as all around. Next is the field and side symbol. So if the welding is going to be done at the assembly location, not where the parts are produced, then we need to apply this symbol. That is, this welding is going to be done on field or site. Here we have the tail option. So in tail note, we can keep the notes for the manufacturer, such as if you are having any doubts regarding welding or what type of welding we require. So I'll say here as gas welding. So after filling tail note, we'll say it OK. And you just need to go and place the welding where required. So I'm going to place it here. You can see here. If I want symmetric weld, means on both the sides, then you just need to go and add the values here also. So I'll take it 5. Same surface finish as counter only. Next, I don't want this intermittent symbol to be taken. I'll keep it flat only. Intermittent welding means there will be a gap in between welding, and then welding will be continued by having some pitch and gap. So if you want intermittent welding, you can go for this option. If you just click on this option, this icon will be shown here. You can see here in preview window. But if I don't want intermittent, I want continuous welding without gaps, then I'll go for this weld symbol as flat. Next, we need to put the length here also. Whatever welding length required. After putting all the symbols, we just need to say OK here, and the symbol will be updated. If I want to go for the symbol for this weld also, again select the weld symbol here. Now I'll take butt weld here. Value as I'll say 3 mm. This will be the radius value for the weld. Type of finish required will be, I'll take here as convex. Here also the type will be single V butt. Finishing type will be convex. Size I'll take here 3 mm only. I'm putting this value on both the sides as I required symmetric weld on both the opposite edges. That's why. Said OK. Click where the weld is to be given. And here you can see. This welding is to be done on this side only as we have shown the flag here. And this is the all around symbol, means complete welding is to be done. So in this way, by using this weld symbol option in annotation tab, we can apply the weldings here. So these were the surface finish symbols and welding symbols in SolidEdge. How we can apply and what the symbol means. So in this lecture we have seen how to apply tolerances to dimensions, how to apply the weld symbol, as well as how to apply the surface finish symbols, and what are the initials in all those symbols. We'll stop here and continue with different types of tables in SolidEdge in next lecture. We are continuing the playlist of SolidEdge drafting. So if you want to learn SolidEdge drafting, please watch the previous videos also and continue following the upcoming videos which we are going to upload. If you want us to make a video on any particular feature, you can comment us in comment section. So till then, thank you and continue learning with 4 Dimensions Infotech.